Before we can really get into talking about scientific literature, we want to make sure that we're all on the same page about what science is. Usually, one of the first things that come to mind when we hear science is the scientific method. So let's take a second and on your own, think about what the scientific method is. Bonus points for writing it down so you can self-check that you got them all. Go ahead and pause if you need some time to think about it, and then come back. There are lots of standard discussions of the scientific method out there, but of the most generic, you'll generally find that first we observe something, which leads to a question, a bit of research, and then we develop a hypothesis. This, in turn, gives us an experiment, which gives us data, which we can make conclusions off from. And this is a beautiful and simple description. But if we look at real science, well, that just doesn't seem to be quite how it works. So based off what you know from science, take a few moments and think about where this doesn't fit. Where are there additions? Is it possible that we would skip a step? Just any variations that you can think of. Same idea, go ahead and pause if you need some time and then come back when you're ready. So while there's never one set path through the method, this is one of the versions that is a much better version of the scientific method. You'll see that the same basic steps are there. However, there's a reversible arrow between the ask a question and do background research. This is an iterative situation. Sometimes your research actually answers your question for you and you're all done. Sometimes it raises new, more interesting ones. When you then get to the experimentation, you have to spend some time working on and adjusting your procedure. Often a non-working experiment isn't about the hypothesis at all, but rather about something that's wrong with the procedure. Then, once you get your data, you need to analyze it. You need to decide how those results do or do not align with your original hypothesis, and then likely continue around in a loop starting back with your new hypothesis. But regardless of whether the results do or do not align with your hypothesis, you absolutely need to communicate them to the wider community so that others can learn from your information. Good science requires so much communication. We can't just sit in our labs, in our lab coats, and be antisocial like some stereotype. The stereotype about scientists really misses the fact that communication is actually a huge part of our jobs. With all that being said, there are some parts of this that we're going to focus on. We want to spend some time talking about what a good experimental design really looks like. To do this, we need to cover some basic use of statistics. You won't be doing all of the math here, but rather learning about the concepts. Because experiments all involve people, even if it's just the experimenter, we have to account for cognitive biases. This will be covered directly in speaking about them, but also in talking about how societal biases can alter how we design and interpret experiments. Once we get into the bottom half of this picture, we want to talk about how data and conclusions are interpreted and discussed in journals. We want to talk about how, as a non-expert in the field, we can still get information about scientific journal articles, both from reading about them and from knowing a bit about the publication process. And lastly, we want to know how things shift when you go from a literature article written by scientists to media coverage written by the press offices, bloggers, non-scientifically literate journalists, and others. This way, you can learn how to use the information you get from the media to trace back to the source and decide for yourself if you should be making personal, professional, and political decisions based on particular headlines. And something that I'd also like to draw attention to, which has become especially important recently, is the way in which we view success in science. While of course we always want to have the correct answer, and theoretically science is our best shot of having that, it isn't as simple as do the experiment which tells us the answer. Science isn't perfect. Researchers doing it have biases, and the society that it is being done in has norms and values, and sometimes there are simply limitations to the technology, the money, or the ability of the researcher. And so when we design or read about experiments, we want to be cognizant of all of that. And when science says, so this thing we said yesterday, we were actually wrong, it turns out it's this way, that doesn't mean that we throw up our hands and say, OMG, we can't possibly know anything. No. It means that science is iterative, and it gets better. And sometimes there's hiccups along the way, but that is science working, improving on itself each and every day. And often, one of the reasons that this gets all mixed up and tossed around in people's heads is that the communication of science isn't as good as it can be. While there are people who are amazing at scientific communication, this is, in and of itself, tends to be a subfield. Typically, scientists communicate to the journals, and then there is a variety of sensationalist steps between those journals and things like IFLS on Facebook, or even something like the New York Times. And this leads us into a question that I think is very important to ask in every class. Students often do this among themselves, but not always out loud. So let's go ahead and voice this. Why do we care? Why should you be interested in this class? Should you just care because I do, and I'm one of the people that are giving you your grades? Well, perhaps I'm a bit biased here, but I don't think so. I think that this class, unlike honestly many others, including others that I actually teach, this can deeply affect the way that you live your life and make decisions. And I think that regardless of what you want to do after school, this stuff is super, super important. Think about how many decisions in our life either are or should be informed by science. These can be at a very personal level. Is that coffee okay to drink? Is that fifth cup okay to drink? Should you go on a juice cleanse? Should you take zinc to stop a cold or other things? Should your dad wait and monitor his PSA or get treatment for prostate cancer? Should your sister have her baby at a hospital or at a birth center? Even if all you want to do is make informed decisions for yourself and to help your family do the same, scientific literacy is important. Then, of course, we can go beyond that to thinking about how we vote. Or, if you want to get into politics, what should you base your stances on? Well, often one party tries to take ownership of science. At its heart, both sides of the aisle commit absolute atrocities against science, and many of these while citing science itself. In our current landscape, you can find some sort of data to back any answer you want to be true. We want to teach you how to manage that influx of both high and low quality data and search for the correct answers rather than your preferred truth. So these are all massive, big, important topics. And in our next video, we're going to start talking about how to go about reading scientific literature in a way that addresses them. For now, we'll end here though.